In this video, I'll show you how to draw a scatter plot in Excel. So I've entered some data into the spreadsheet. They're test scores for a science test out of 30 and a maths test out of 40. So here are the scores out of 30 for science, scores out of 40 for maths. Usually when we have science data, we'd have the independent variable on the left-hand column and the dependent variable on the right-hand column. But that's not important here. So how do we do this? First of all, we select the data, clicking in the top left-hand corner of the data, dragging to the bottom right. Ignore the headings, we can put them in later. So just the data. Then we go Insert. We want a scatter plot. We choose the top one because we just want the dots. And there we have it, a crude scatter plot. We can put it where we want it on the page. Make it bigger if we want to. And then, of course, the thing we need to do is to put headings on, label the axes, and so on. So we go here to Chart Tools, Layout, Chart Title, usually above the chart, and we can just type in straight away that this is marks for tests, or marks for maths test versus marks for science test. Hit enter and the heading is there. Next thing we need to do is to label the axes. So we go to axes titles, the horizontal axes we're going to put below the axis. So we type in that that was the science scores. Usually you put in the units as well. This one there's no units, they're just marked, but we'll say this one was out of 30. Enter. So we have the x-axis labeled. Now axis titles, the vertical axis, we've got some options here. Let's do the title vertically. We can just type in, these were science marks. Again, we'd put in the units, but there's no units. Just let's say it was out of, this was maths marks. And they were out of 40. Hit enter, and we have our axes labeled. We could delete this just for neatness because we only have one series. So right click on it, delete, and it's gone. There's our basic scatter plot. Now, the next thing you know from science is we try and draw a line of best fit. Now, that's called a trend line in a spreadsheet. So we could go up here to trend line, but I prefer to right click and add trend line. Then you get all the options in front of you. It's a better option. So we do add trend line. Now, three things we need to do here. We need to guess the type of regression. It might be an educator guess. In this case, we want linear. But in other work, we might want to try these and see which is the best fit. In a minute, I'll explain how you tell which is the best fit. But let's just go for linear here now. Other thing we want to do is to display the equation of the chart. That'll be the equation of the line of best fit. And the other thing we want is this thing called R squared. I'll explain that in a minute. So we click it on and close, and there we have it now. Let's make it bigger. And this now tells us here is the line of best fit. See the points scattered evenly about it. And that equation has that line has equation 0.6267x plus 19.132. We might want to round that off to a suitable accuracy. And also you might like to change the y to, say, be m, something meaningful, m standing for maths marks. And you might want to change the x, what was on the horizontal axis, the science score. So you might want to change that to s. So you might say this is maths mark equals 0.6267 s, the science mark, plus 19.13. That's an equation then that enables us to predict any math score given a science score. Or because you know how to solve equations, you could be, say, given a maths mark and predict what the science mark would have been. So that's the equation and how we can use it. Now this R squared thing, 0.8134, that number tells you the strength of the relationship. So 0.8134 is pretty strong. The numbers vary from 0, where there's no relationship, up to 1, which is a perfect relationship, the terms that we've used in looking at this work over the last few days. So there we have it. How you draw a scatter plot in Excel, determine the best line of best fit, determining the equation of the line of best fit, and determining how strong the relationship is.